Welcome back. In part 1 of this video, we talked about how the Elastic Load Balancer or ELB helps distribute traffic across multiple targets like EC2 instances. We also talked about the different types of load balancers in AWS. And finally, from AWS console, we launched 2 EC2 instances and set up an ALB to balance the traffic between these two instances. Now let's explore some more key concepts about ALB. First, let's talk about security. In the previous video, I mentioned that when you use a load balancer, it becomes the point of entry for your application, meaning all user traffic will directly connect to the load balancer. The load balancer then routes the traffic to your backend targets like EC2 instances. So, while the load balancer security group allows incoming public traffic from the internet, the EC2 instances behind the load balancer should remain private and only allow traffic from the load balancer's security group. This ensures that no one can access your instances directly, keeping your infrastructure secure. To do this, the inbound rules of the load balancer security group should allow public traffic from the internet, typically on ports 80 for HTTP traffic and 443 for HTTPS traffic. At the same time, the inbound rules of your EC2 instances security groups are set to allow traffic only from the load balancer's security group. This way your instances are protected from direct internet access but can still receive traffic from the load balancer. Let's proceed to the AWS console to implement this now. So log into your AWS Management console and then navigate to the EC2 dashboard. In our current setup, we have 2 instances in running state. If you're new here, please check out part 1 of this video. And these instances can be directly accessed from the internet. Select one of the instances, copy the public IP and open it in the browser. We see a simple HTML page from instance 1. Similarly, check for the instance 2. We can see that both the instances are publicly accessible from the internet. Also, we can access these 2 servers from the load balancer. Go to load balancers, copy the DNS name and open it in a browser. Refresh the page and we see that the load balancer balances the traffic between the 2 instances. So, what is happening here is the users have direct access to the load balancer as well as the 2 backend instances. But this is not an ideal scenario. The users from the public internet should not be able to access the EC2 instances directly. So, let us make some changes in the security group of the 2 EC2 instances now. Go to Security Groups under Network and Security section and open the security group of your EC2 instances. In my case, it is the Launch Wizard one. If you are not sure about the security group of your instances, just go to the instances and scroll to the right to get the security group name. Okay. Open the security group. So we have to edit the inbound rules now. Delete this rule and then add rule. The type will be HTTP and source is custom. and instead of the CIDR block, we'll choose the security group, and that is the security group of your load balancer. In my case, it is the ALB SG security group, and then save rules. Now the EC2 instances will only allow inbound traffic from the load balancer. To verify this, again copy the public IPv4 address of each of your instances and open it in a browser. We see a timeout error. You can check for the other instance as well. Now let's check the DNS name of the load balancer. Refresh the page multiple times. We can see the response from both the instances. So this is the ideal way to set up your load balancer and the backend targets with regard to security. Now let's move on to health checks. Health checks are vital for ensuring that your EC2 instances are performing well. The load balancer automatically checks the health of your instances by sending requests to a specific path such as a / health or any custom endpoint you choose. If the instance responds correctly, it's considered healthy and will continue to receive traffic. If an instance fails the health check, the load balancer will stop sending traffic to it until it becomes healthy again, routing traffic to the other healthy instances instead. In this diagram, suppose the target 1 becomes unhealthy for any reason, then the load balancer does health check, and if it does not get a response code of 200, typically it is 200, then automatically it routes to target 2 or target 3. And when target 1 becomes healthy again, the load balancer will route the traffic to all 3 targets. Let's move on to the AWS console now. From the EC2 dashboard, open the target groups, select it, and then open the Health Checks tab. In our current setup, we are using / as the path for health checks. This works perfectly fine for our simple application which just serves an HTML page. However, using a dedicated health check endpoint like /health or any custom endpoint is a good practice. For this demo, we will just continue as it is. Currently, we see both our targets are in healthy status. Now let us simulate an unhealthy status by stopping the Apache web server on one of our instances. To do so, we have to connect to our EC2 instance. Before we can connect to our EC2 instance, we have to make some changes in our security group. Currently, the security group of our EC2 instance allows only HTTP traffic, but to connect to the instance, we have to allow SSH traffic as well. So go to security groups and open the Launch Wizard 1 security group, which is the security group for both our EC2 instances. Edit inbound rules, add rule, and then add a rule for SSH traffic. Save rules. Now we can connect to our instances. Now go to instances. Let us select instance 1. We will use the EC2 instance connect to connect to our instance 1. So click on this connect button. Select the EC2 instance connect. and then click on Connect. This will open an interactive terminal directly in your browser, allowing you to run commands on the instance without needing any SSH keys. Once you are connected, run the following command to stop the Apache web server. This will stop the Apache server on your EC2 instance 1. So the instance 1 will no longer respond to HTTP requests. When the load balancer performs the health check, it will now fail, marking the instance as unhealthy. Go to target groups. We can see that the instance 1 is marked as unhealthy now. Now open the DNS name of your load balancer in a browser and then refresh the page multiple times, but you see that you get the response only from instance 2. This is because the instance 1 is marked as unhealthy, so the load balancer will only route your request to instance 2. Now let us restore the instance 1 back to healthy state by starting the Apache server again. Run this command. After a few moments, check in the target group. We see that instance 1 is healthy again. To verify this, connect to your load balancer from the browser. Refresh the page multiple times. Now we can see response from both instance 1 as well as instance 2, thereby indicating that the load balancer is routing traffic to both the instances. So this is one of the advantages of using a load balancer. It not only routes traffic to your backend instances, it also makes sure to route traffic only to healthy targets. In my next video, let us explore some more features of the application load balancer. If you have any questions, please drop a comment below, and also please subscribe to my channel for more such tutorials. Thanks for watching.